In this episode, we're taking a look at some of the first moments in the life of a new planet. Stick around and we'll be taking a look at some of the baby pictures. This is a picture in 1,000 words. Welcome to A Picture in 1,000 Words, where I go into some of the details of your favorite space pictures from the perspective of an astronomer and uncover some of the stories underneath it all. This week, we're going to be taking a look at the twisted disk of AB Aurigae. Now, this is a really cool star that we're catching at a really specific time in its life, so let's jump right in. So this is an image that was taken with the Very Large Telescope in Chile that is run by the European Southern Observatory. Yes, we don't have a lot of creativity when it comes to naming some of our telescopes. But this is the region around the star AB Aurigae. And as you can see, the star itself is actually blocked out of the image because it's so bright so that we can see the rest of everything that's going on. Now, this entire region over here, this is approximately 1/450th of a degree on sky, and that's not really easy to parse. So the best way to think about it is if you took a human hair, stuck it out, into an arm's length, that's roughly the size on sky. Now, this region, the star itself, is about 520 light years away, and that's not super close. It's not our next door neighbor star, but we're still in the same neighborhood. It's not super far as stars go. And that means that at this entire region, we're talking this entire area is approximately 0.2 light years away, or the time it takes light to travel, or the distance that it takes light to travel, I should say, in about 2.5 months. So sounds big for anything that humans really think about regularly, but it's actually a fairly small region. And we're super zoomed in here. So this image is fully taken in the infrared, and that's all you're seeing. You're seeing one color of infrared light, which is light that is redder than your eyes can see. And all of the colors that you're seeing here, that red, that yellow, that orangey stuff, all of that stuff, that is just put in there to make it easier for our eyes to see detail. There's nothing special about these colors. You could choose your own colors if you wanted. But this is one way to see some of these features more strikingly than if it was just in black and white. This is something that astronomers do regularly to better understand the structure of what we're seeing. This infrared light that we're seeing is basically showing us a lot of dust. And so that's what we're seeing here is a lot of dust. And by a lot of dust, what I mean is bits of carbon, bits of oxygen, bits of nitrogen, all sort of packed together as molecules that are emitting a lot of light, and they're emitting it in the infrared wavelength. Should note that the vast majority of the gas that's in here, the stuff that we're actually seeing, is hydrogen gas. But the reason that we don't see it is because the light is mostly being produced by the dust. It's the same concept as if you took a glass of water, put some food coloring in it, just like a drop, mixed it up. The vast majority of what you're seeing there is the food coloring, but even though the vast majority of the atoms that are in that cup of water are still water, not food coloring. And so that's the same thing that's happening here. We're using the dust to be able to see where much of the gas is. It's a tracer. So let's talk a little bit about the star AB Aurigae. Now, again, you can't really see it in here, but this is a fairly young star. This is less than 10 million years old. And just to give you a sense, our sun is about 5 billion years old. And so something like 500 times older than this particular star. So this star has a disk of gas and dust around it, and that is primarily what we're seeing here. And this is the stuff that didn't make it all the way into the star when it was being formed from clouds of gas. All of this stuff is just leftover material from when the star was forming that will form all of the planets and all the other stuff that seem to go around a lot of these kinds of stars. So we're catching the star at a very special moment. We're seeing it at the phase where some planets are being formed for the very first time. So we're seeing this entire region face on. So what that means is most of this, if you imagine that the star was something like this, all of the leftover gas that didn't make it all the way into the star would form a disk like this. And all of your planets and all of your comets and all that fun stuff, all of that forms in this disk. And we see that similar in our solar system. That's why when you take a look at planets, they generally seem to fall in the same line on the sky. And that's because they all formed in that same disk and continued orbiting the star in that same way. Otherwise, it would be kind of weird by chance if all of the planets seem to, line up in the same line. So you can imagine if this was all forming in a disk and all of the disk was just kind of spinning around in this direction and just kept on, going around and around and around, it would just continue to sort of rotate and there would be no structure to the disk itself. But what we're seeing, as you can see very clearly on this image, are these incredible spiral structures. And so what's got to be happening here is something's got to be perturbing the disk, or something's got to be, shaking it up and leaving a wake in its presence. So it's the same thing as if you took a paddle and you put it in water and shaked it or moved it, that would create a wake behind it. And these sort of darker regions look like what that wake might be. Given these spiral features that we're seeing, there's got to be something messing with the disk. There's got to be something there that's clumping it up and leaving a big wake. And what we think it is the formation of a new planet, that there's a new something that is starting to clump up a lot of gas, and that's what we're seeing. So if we zoom in to this region and take a look over here, this is what astronomers seem to think might be a newly forming planet in this entire region. And one of the easy ways that you can tell is if you notice the spiral arm kind of kinks over there, right? This seems to be creating sort of a bend in the spiral arm, and all of this stuff over here seems to be the wake of that region. And scientists who've been working on this think that it's anywhere, this entire clump, think that it's anywhere between 3 to 13 times the mass of Jupiter. And so it's a fairly large planet, and the radius of this, if this was the center, this is roughly at the orbit of what Neptune would be in our own solar system. So we're talking about a big planet that's fairly far away from the star. What's cool about this is that this is giving us a glimpse at some of the first stages of how a planet forms around a star. And this is something that we've been trying to figure out for a century at this point. How did the Earth get here, and how did the solar system form? And is the solar system kind of normal for how planets form around a star? So this key insight allows us to understand where this is all coming from. That's all the time we have for this episode of A Picture in 1,000 Words. Be sure to like, share, and subscribe, and check out some of our previous episodes, and leave a comment if you have an image that you want us to take a look at and explain from the perspective of an astronomer. Your fun fact for today is that this kind of infrared light is next to impossible to see from the ground because it gets absorbed by the water in the atmosphere. And as you go up, let's say on top of a mountain, there is less water in that atmosphere up there than there is at ground level. And so that's when you can start seeing some of this infrared light come through the atmosphere. That's why all of these telescopes that look at the infrared tend to be on top of really high mountains. Until next time.